Now the first kind of actual graph that we'll do for numerical data is a histogram. So it's probably been a while since you've made a histogram or worked with them, but those things that we said at the beginning of the unit about what's included in graphs, they're all kind of on display here for a histogram. So one, we want to have what I call the skeleton. We have a title, and so we're putting the age of the 10 random Americans. We're going to use the same set of data, same thing. We made the data chart for ages of the 10 Americans, 20 to 30 all the way to 60 to 70. And we'll have a vertical and a horizontal axis. And so for histograms, almost always your vertical axis is going to be frequency. And so on the frequency, 1, 2, 3, 4, we're doing units of 1 up. And the reason that I chose 4 as my highest value on the frequency is because the class that has the highest number of items in it, the 4 people, are in their 20s, and so I want to make sure that kind of the top of my building will be able to be seen on the graph. I label this as frequency. On the horizontal axis, age, and I put my years as a unit, is labeled here. And I have a skip here because there was no one under 20 years old, and so kind of skipped the 0 to 20 and did the double slash mark there, and then 20, 30, 40, 50, 60, 70. And so we have the ages with the uniform spacing. Okay, and so this is what I'll call the skeleton, and because labeling axes is very important, the uniform spacing, context, title, they're all very important. And now, actually making the histogram, that's actually not that difficult. We said there were 4 people between 20 and 30 years old, 3 between 30 and 40, 2 between 40 and 50, none between 50 and 60, and 1 between 60. And so we can make each of those. And here we go, and there's our graph. And sometimes I'll label the top of my bar, or building as I call it, just to make it clear to the reader how many there are in that group. Okay, and there's our answer. Okay, and so how is this good? It tells us the shape of the distribution. Now we haven't talked about the shape yet, but we can tell here that kind of with the shape, it's kind of heading down as we go to the right, and the shape is actually called right-tailed or right-skewed. Okay, and we can find that out from looking at the histogram. It's useful for large data sets. Like if we had thousands of people, we could scale down the frequency, and maybe instead of for everyone being 1 item, maybe it's 100 or even 1,000 for every tick mark here, and we can scale it down. One of the detriments is that we lose the individual data values. For example, if we're just looking at the histogram and we don't have the data table next to it, we can tell that there are 4 people that are at least 20 but less than 30 years old, but we don't know if they're all, say, college students in their low 20s or if they're in their mid-20s, how that's spread out within the class. So because of that, we wouldn't be able to calculate a mean, the average of these people, based on the histogram, because we don't know the exact ages of the people in there. We could find a range of the median, the middle value in an ordered set of data, by going in. There are 10, and so we would take the average of the 5th and 6th, so we would count from the outside. So we know there's 4 in this lowest group, 1 in the highest, and then 2 in the next to the highest, and then 3, and then so this is where it meets, and so this is where the 5th and 6th highest values are, and so the average of those. And so we know the median is somewhere between 30 and 40 years old, but we don't know exactly what that is. And we know that the range could be anywhere from 30 years old, the distance from the lowest class, which is 30 at the upper end there, to the lowest of the highest. So that's a 30-year range. Or it could be, since 20 is the lowest and 70 is at the highest there, it could be as much as 50 years. So we know the range is anywhere from 30 to 50 years old, but we don't know exactly what that is. Okay. And so describing the data set, we'll get to that a little bit later. But we can also make box plots and parallel box plots. Okay, and so here's an example of parallel box plots. Parallel box plots can run either vertically, the way they are here, or in the way that we've done. We could have the numerical scale going across the bottom, and we could have the box plots or box and whisker plots running horizontally. Either way is fine. And so there's 5 values that are used to do this for each of these. And so the horizontal axis is education level, and the vertical axis here is total income in thousands of dollars. And so for each, there's 5 values used to summarize them. The minimum value for each, the first quartile, which is basically the median of the lower half of data values, the median, middle of an ordered set, the third quartile, which is the median of the upper set of values, and the max. And so that tells us something. It tells us the measure of middle would be median, kind of the typical, and we can find the min and the max from that. And that's called a 5-number summary is used to make a box and whisker plot. It's called a box and whisker plot. 5-number summary. The minimum value, the first quartile, the median, not the mean. We use the mean a lot, but this is the case where we use the median, the third quartile, and the maximum value. Okay. And then, so we've talked about histograms and we've talked about box and whisker. That's it for this one.